So welcome students, let us look at our first question. So my first question is based on some theoretical concepts. So we know that n of A union B is equal to n of A plus n of B minus n of A intersection B. So this is a standard theorem that we have. Now if n of A and n of B are given to you, so what is the condition which ensures the maximum value of n of A union B? If n of A and n of B is fixed, A union B, n of A union B will be maximum if A intersection B is equal to 0. If these A and B are disjoint sets, so you are subtracting 0 from this, so then the maximum value of n of A union B will be exactly equal to n of A plus n of B. And what is the minimum value of A union B? The minimum value of A union B will happen when one set goes inside the other set. Assume that you have one set which has 4 elements, the other set which has 7 elements. If these two sets are disjoint sets, then A union B will contain 4 plus 7, that is 11 elements, because there is no intersection. And so if one set lies inside the other, it's obviously the smaller set lies inside the bigger set, then n of A intersection B will be maximum, and this ensures the minimum value of n of A union B. So n of A union B will be exactly same as the number of elements in the bigger set. So the maximum value of n of A union B will be equal to n of A plus n of B when the sets are disjoint. The minimum value of n of A union B is the maximum of these two numbers, obviously because the smaller set will go inside the bigger set. So A union B will be the bigger set itself. Hence the minimum value of n of A union B is the maximum of n of A and n of B. Similarly, what is the maximum value of n of A intersection B? So when two sets are given to you, what is the maximum value of n of A intersection B? It's nothing but the minimum n which is there, the minimum of n of A and n of B. So obviously because if there should be maximum intersection, one set, the smaller set, has to go inside the bigger set. Because the first set has 4 elements, the second set has 7 elements, there cannot be more than 4 common elements. If all the elements of A are also present in B, then you have all the 4 common elements, then n of A intersection B will be maximum equal to 4. So I hope you understood this concept. Maximum value of n of A intersection B is minimum of n of A and n of B. So once we have these 3 formulas, these are very useful formulas. So let us take this question. N of A is given as 4, n of B is given as 7. What is the maximum and minimum value of n of A union B? So the maximum value of n of A union B is nothing but n of A plus n of B. This happens when the sets are disjoint. So you have 4 plus 7 is equal to 11. That's the maximum value of n of A union B. So what is the minimum value of n of A union B? That's nothing but the maximum of these two numbers, that is 7. So that will be the minimum number because this set has 7 numbers, this set has 4 numbers. So when you combine them, you cannot go less than 7 because there are 7 numbers in one of the set. So n of A union B will be at least greater than B. Hence 7 is the minimum value of A union B. 11 is the maximum value. If you are also asked to find the maximum of A intersection B, maximum of n of A intersection B, that will be equal to 4. So I hope you have understood this question. So let's go to the next question. So next question is, you're given that A union B union C is equal to the universal set. That is, if you combine A, B and C, you get all the elements in the universal set. And you're asked to find A minus B union B minus C union C minus A whole complement. So you're given 4 options. You're asked to find which is right. So to solve this question, so let us make use of Venn diagrams. It's a question based on Venn diagram. So let us draw the Venn diagram correspond to this set. So you have A, you have B, you have C. So let this be A, let this be B, let this be C. Now you're asked to find A minus B union B minus C union C minus B. So what is A minus B? So this is my A minus B. The elements present in A but not in B. It's A minus B. What is B minus C? B minus C is all elements present in B but not in C. So this is B minus C. And what is C minus A? C minus A. The elements present in C but not in A. So C minus A will be something like this. C minus A will be this. And you're given that A union B union C is equal to U. That means there are no elements in this outside region. This outside region is empty. This outside region is empty. So what is A minus B union B minus C union C minus A? All the shaded portion. So you're asked to find the complement of A minus B union B minus C union C minus A. Complement means all the elements except the shaded portion. So as you can see, the remaining portion is just this area, right? This area is remaining and the area outside is remaining. But area outside is a null set because all these three sets combinedly form the universal set. So there is no other region which is apart from A, B and C. Hence, A minus B union B minus C union C minus A whole complement is this region. So what does this region represent? Obviously A intersection B intersection C. So option C is the right answer. So next, let us look at this question. This question you're given that A union B union C intersection A intersection B complement intersection C complement intersection C complement is equal to what? So let us again solve this question using Venn diagram. So let us draw a Venn diagram correspond to the situation. So let us take three sets A, B and C. So this is A, this is B and this is C. So you're asked to find the intersection of three different sets. So let us try to shade all these three sets and find the common checked portion. So what is A union B union C? A union B union C is the region correspond to all A, B and C. So this is your A union B union C. Next, let us go for A intersection B complement intersection C complement. What does this mean? That the elements have to belong to B and should not belong to, the elements have to belong to A and they should not belong to B and they should not belong to C. So what are the elements in A which are neither belong to B nor belonging to C? That is this region, right? This is the region which is belonging only to A but not to B and C. So till these two sets, the intersection is this. And now the third set is C complement. The third set is C complement, is all the elements except those present in C. All the elements except those present in C. So let us shade this region using slant lines. So all the region except that region corresponding to C. If we just leave C, we just need to shade the whole region except C. Now you want the intersection of all the three sets. That is, you want the region where horizontal lines are there, vertical lines are there, as well as checked lines are there. So can you see the region? So this is the region which we are talking about. This is the region which contains all the three lines. So this will be the region that you want. So let us go to the options and see which region corresponds to this. B intersection C dash. B intersection C dash, elements in B but not in C. No. A intersection C is this region, not this region. B dash intersection C dash, elements which does not belong to B and does not belong to C. So if we just have B dash intersection C dash, this is nothing but B union C whole dash, everything except B union C. So you get the outside region also with this. So I just want this region. So answer is none of these.